So in today's video, we're going to be looking and thinking about some quantities that we can measure and the units that we use to measure them. So we're going to start out with mass as an example. And one way that you can measure mass is in grams. This is a very chemistry answer. But for you and I, if we were going to measure our own mass, we might step on a scale and maybe we would weigh ourselves in pounds. Pounds is another way to measure mass. We could also think of things like ounces. Ounces is something we might use to measure a steak. Or if we were going to measure ourselves in a metric system, we might think of measuring ourselves in kilograms. All measurements of mass, both in the SI system or the metric system and in our imperial measurement. Length or distance is another thing we could measure. If I were to ask you, how far away are you from your bed or from your couch? You might give me an answer in feet. Or if I asked you how far away you are from the beach, maybe you would answer in miles. In the metric system, we like to measure in things like meters. Or if you are measuring the distance between your eyes on your face, you might measure that in centimeters. These are all units of measuring distance or length. Another unit we might measure would be something like time. If I were asking you how long this video was, you might check and answer me in minutes. If I would ask you how long this video felt, maybe you would tell me hours or days. And how long have we been in quarantine? Well, that has to be years. These are all units of measurement. They're not all considered standard units of measurement, but they're all considered measurement. In the United States, we use the imperial version of measurement in feet and miles, minutes, pounds, ounces, where in most of the rest of the world and in all of science, they use the metric system. So time, length, volume, mass, those are all units of measurement, but they're not all considered miles, feet, meters, gallons. They're not all considered standard units of measurement. The standard system of measurement that we use is called le Système International des Units, or the International System of Units in English. And this system was adopted from France during the French Revolution, and it is used throughout the entire world with the exception of a few countries, one of them happening to be the United States. So most of the world uses the metric system and all of science. So for the purposes of science class, we will be learning the metric system, its units of measurement, and how to convert within it. Because if we're going to do science, we need to be speaking it. Within the international system, there are 7 basic units upon which all others are derived. So there are 7 things that we can measure. We can measure mass, as we mentioned before. The abbreviation for measuring mass is a lowercase m. The unit that we use to measure mass is the kilogram, because a gram is about the weight of a paperclip. And so that's a little bit too small to measure much. And so for the most part, mass is measured in kilograms or greater. The second unit that we could measure would be length, lowercase l. And we measure length in meters, abbreviated by an M. You can see my M's are already getting used up. M's are a hot commodity in science. M as a unit of measurement is quite common. We're going to see that right in just a few minutes. We can also measure something like the temperature. Temperature is abbreviated by a capital T because time, which is another thing that we can measure, is going to be our lowercase t. Temperature is measured, can you guess? What do we measure temperature in? I bet you said Celsius, and you're not wrong that the metric system does use Celsius, but in science, we actually use a unit called the Kelvin, capital K. And the Kelvin is a really cool unit of measurement that sets the coldest temperature possible on Earth, which we call absolute zero, at 0 Kelvin and works up. And so we like Kelvin because it's all positive numbers. And you probably know from being in a math class that when you have a number that's sometimes positive and sometimes negative, like there's a positive 20 and a negative 20, it really messes up your algebra. So we want to keep it as a positive number. Time is measured in seconds and abbreviated with an S. And then the last one that we have, well, the last chemistry one we have, the 6 and 7 are going to be physics quantities. But the last chemistry one we have is the amount of substance. It's represented by the number N, and you can think of that as like the number, like N for number. And the unit that that's measured in is called the mole. The mole is a word that means a number, just like a dozen means 12. The mole happens to mean 6.022 times 10 to the 23rd. It's a big number. But the mole symbol is MOL. And I like to joke that this is the worst abbreviation in all of chemistry. All we're saving you is one little E. But as you can see, even just from this, meter and mass, they're already taking up the M's. Molybdenum, MO, is an element on the periodic table, so we can't use that one. That one's already taken. And so we go with MOL as our measurement for the amount of substance or the number of something that's in a sample. There are some other measurements like luminous intensity used to measure light, and that's measured in candelia. And we have electric current, which is measured in amperes or amps, okay? But for our purposes, these ones, they're really not a part of our topic. These are not a part of something that we're going to be seeing. So even though I am introducing them here, and I do expect you to know them since I'm giving you a place to write them down and all of your tests are open book, we're not going to see them later on in the semester. All of these ones I am introducing now because we will be using them as time goes on. So 1 through 5 will be measurements of quantities and units that we are going to be using as we continue through the chapter.